Good afternoon, everybody. Thank you to be here. I am Tiziano Denis Gatti. I work in the Marzocchi Pompe technical department as a product engineer. And here I want to introduce to you our efficient solution for the hydraulic systems of the electric vehicles, the E05 external gear pump. So here a brief introduction of Marzocchi Pompe company. It was founded in 1961 in Bologna, in Italy, by Marzocchi brothers, and since the beginning it has been specialized to manufacture external gear pumps and motors for several hydraulic applications. In this slide you can see our product range. For example, the micro pumps on the left side of the slide, 025, 05 gear pumps for microhydraulics, and the 1P and the 1P pumps for power pack applications. And so on the other figures, the other pictures show the rest of our products used in several hydraulic field applications, for example, industrial, agriculture, construction machinery, and so on. The displacement, the entire displacement range goes from 0.12 cubic centimeters per revolution up to 200 cubic centimeters per revolution. The argument of today is the E05 pump, specifically designed for the automotive range. Its displacement goes from 0.18 cubic centimeters per revolution up to 2 cubic centimeters per revolution. And let's take a look to this product. It has been completely designed beginning from our microhydraulic pumps, and it is targeted to medium high production volumes, so typical production volumes for the automotive fields. The performance, thanks to the complete design of the components, the optimizations of the manufacturing process are very, very high. For example, volumetric efficiency is and the mechanical efficiency high. In this slide, you can see two exploded views of our products. The components of the pump are quite similar, quite the same as a normal external gear pumps. But we have optimized the design of the case of the pump. Normally, we have three components in an external gear pump. Front flange, a body, and a rear cover. In this case, to reduce the pump length and pump dimensions and to reduce the manufacturing cost, we have realized one piece for front flange and body. And also a rear cover, both are in die-cast aluminum. You can see the driver gear, coupled with the electric motor, the driving gear, and the two plates with their own seals. What we have for this pump is two different configurations. The double compensation pump with two plates that ensure the contact between the gears, reducing the internal leakages of the pump and giving a higher volumetric efficiency. And the single compensation pump with only one plate on the flange side. The difference is that in this case we can work up to 180 bars. In the higher case we can work up to 80 bars, but we can save 4 millimeters in total length. So we have three different configurations of the pump. About the port. You know, we have two ports in the pump, so an inlet port and an outlet port. The first configuration is what we call the KA version. You can see a front side view of the pump. This is the driver shaft, and the rear side view of the pump. With light blue arrows, we have indicated the inlet port. With the red one, the outlet port. As you see here, we have both ports on rear cover of the pump. The KX version is the opposite one. Both ports are on the front flange and we used two different seals for block cores. An hybrid configuration, respect to the previous two, is this, the K version. We have the inlet port in the rear cover and the outlet one on the front cover. We can have clockwise rotation or counterclockwise rotation. The pump can be used in tank application and even for external application. And the level of customization of this product is very good because we can supply different kind of shaft configuration, also different board position. Let's take a look to our, just a brief look to our production capability. We manufacture our products in our plants in Italy. We are certified AITF 16949 and ISO 14001 and also ISO 9001. We have a dedicated plant to automotive pump production with automatic lines, where we have the full components traceability, and we test all the pumps we produce, we manufacture at the end of the line. We have set parameters with minimum values of mechanical and volumetric efficiency. And we store all this data, and this data can be used for following requests, for example. And if a pump during the performance test does not have at least, if a pump has a value of mechanical or volumetric efficiency lower than the minimum we have set, it cannot go farther in the production process. Our application, the application of the E05 pump in the automotive sectors are quite different. For example, for hydraulic power steering, clutch and gear, semi-automatic gear shifting, hydraulic suspension, spoiler, and wings actuators, and for transmission system. In particular, for this application, we currently supply the E05 pump as to connect or disconnect a four-wheel drive transmission. For electric or fully electric or hybrid or plug-in hybrid vehicles, the E05 pump is particularly suitable thanks to its high efficiency, to its low noise in order to reduce the MVH components, and thanks to limited overall dimension we have seen in the slide before, the very compact design of this pump. Here you can see just an example of an integration between our pump in the KA version. You can see the both cores on the rear cover and an electric motor. Here we have a different example or application between pumps and motors. We want to show in practical what the E05 pump can do for an automotive applications and which are its performance, real performances. So we have made a comparison between the E05 pump and Jaguar pump. This kind of pump is widely used in the automotive field, especially as fuel pump or for lubrication system. It is very compact, and it is, of course, an economic product. Here you can see the characteristics of the two products. We have 0.35 cubic centimeters per revolution of displacement. Instead, the E05 has 0.375 cubic centimeters per revolution. The maximum speed is the same, 6,000 RPM. The max operating pressure is quite similar, 60 bars for the Jaguar pump, 80 bars for the E05 pump. Both pumps are with single compensation system, so if you remember, only one plate for E05 pump on the flange side. The field parameters are, of course, different because this pump it is designed with different concepts. What we have measured in our R&D department are the parameters you can see on the right side of the slide. For example, the volumetric and mechanical efficiency, the absorbed torque and power, and we also made a simple simulation of an electric motor current and power absorption I will tell you about this simulation in the next slides. Also, the test conditions are the following. So we have used a pentacene CHF11S oil that is widely used in the several automotive transmission applications. The pump speed was set at 3000 RPM, and the pressure level goes from 5 bars up to 60 bars. We have measured the performances at 3 different temperature levels of the oil, 20 Celsius degrees, 50, and 80. And this is what the data we have collected in this slide, and in the next ones you will see the similar layout. On the left, the data on a graph represented by curves. On the right side, a graph in bars. We have highlighted the 3 different temperature levels with 3 different lines shapes. And the Geroder pump data are represented in yellow, the E05 pump in green, and we have in the vertical axis the volumetric efficiency in percentage, on the horizontal line the pressure levels. On the right graph we have the same data layout, but for the first 2 bars, we have the first 2 bars represent the 20 degrees oil temperature, the second 2 the 50 degrees, and the last 2 80 degrees. What we can see is that the trend of the volumetric efficiency of the Geroder pump here in yellow is decreasing as the pressure increases. Instead, the E05 pump has a more constant trend for volumetric efficiency. In particular, we can see that when the temperature of the oil is high, when the pressure level is high, and also the temperature of the oil is high, the difference between the pump is remarkable. For example, here we have about 40% of volumetric efficiency for the Geroder pump and around 80% for the E05 pump. In the next slide, same graphs layout, but we have the mechanical efficiency. So in vertical axis, the value in percentage, in the horizontal line, the pressure levels. The usual trend for a pump for the mechanical efficiency is it increases as pressure level increases, and also here the trend of the mechanical efficiency of the E05 pump is quite clear. We have higher values for mechanical efficiency respect to the ones in yellow here of the Geroder pump. This means that the absorbed torque by the pump is of course higher for the Geroder pump, and also here we have the representation of the torque in Newton per meter, and we can see on both graphs that the absorbed torque for the Geroder is higher than the one of the E05 pump here in green color. So let's wait one second, please. Here we have the remarkable difference, especially at low pressure levels, but also in the high for the high values of pressure. Consequently, also the absorbed power, because of both mechanical and volumetric efficiency of the E05 pump are high, the absorbed power is lower for the E05 pump than for respect to the Geroder one here in orange, and you see the E05 pump values in green. We also made a very simple calculation in all over the temperature range, so 20, 50, and 80 degrees, and we have the value of the power in the vertical axis. Here in orange, the Geroder pump absorbed power, in green the E05 pump absorbed power. I apologize for the invisible value here, but this is the orange one. The orange color, you can see the Geroder, and the green E05. Also here, with simple average calculation, the absorbed power of the E05 pump is lower in all the pressure range from 5 bar up to the maximum pressure, that in this case was 60 bars. I talked to you about an electric motor simulation. We have considered a typical electric motor used in the automotive field. We have considered its efficiency at all these different pressure levels. So here we have ever the same pressure level we have seen in the slide before, so from 5 up to 60 bars. In vertical axis, we have the power expressed in watt, in the left graph. In the right one, we have the average current absorption in ampere. And also here, the power absorbed by an hypothetical electric motor that moves the E05 pump is lower than the ones which moves the gerotor pumps. Also, of course, consequently, the current absorption is lower for the electric motor of the E05 pump. This means that for the same application and the same working conditions, the motor that you need to move the E05 pump is of course smaller because you need less power, and it has a lower power and current consumption for a modern electric vehicle or hybrid or plug-in hybrid electric vehicles. This means that you have a higher battery autonomies, and you can use this power, this current, for other purposes. We also measure the power saving. This is a very simple calculation because we have in vertical axis the percentage of the power, and in the horizontal one also the pressure levels. We have a maximum power saving of 55% at 5 bars, and 22% of power saving at around 50 bars, but the average value is 36. This is a simple difference between the power data we have seen in the slide before of the gerotor pump and of the E05 pump. In the next slide, the last one, we have also measured, you can see the data of the noise of the pump. I talked to you about all the optimization work, all the optimization design that has been made on this pump. We have made several improving of the manufacturing processes, especially of the gears. We have improved our precision of the surface finishing, the finishing process, the turning process of the gears, and of the old pump inner components. For example, the body, the internal machining of the body has been improved to obtain a very low internal leakages, and so a very high volumetric and mechanical efficiency. As you know, to reduce the noise components and the pulsation components during working conduction is crucial to have very low internal leakages. In this case, we have measured the noise level at 1 meter of distance. You can see in the vertical axis the sound pressure in dBA. We have collected the data in different range of speed from 1,500 up to 4,000 RPM at 3 different pressure levels: 20 bars, 40 bars, and 60 bars. In orange, you can see the gerotor data. In light blue, the E05 pump data. And in this case, we have that higher speed, the noise level is lower for the E05 pump at all 3 pressure levels. This is the last graphs. I will say thank you to you for your attention, and if you have questions, please. I'm here for your questions or doubts also. Thanks for your attention.
So let's get this speech.